we're back. And the first thing we can observe is that, look, the rotation through angle theta can be undone by rotating through an angle minus theta. So we know that the inverse of the transformation r sub theta is the transformation r sub minus theta. We also know that r sub theta of x for any angle theta is represented by this matrix right here, which involves cosines of theta and sines of theta. We therefore know that all we have to do is plug in minus theta to come up with the matrix that represents the inverse transformation. Finally, you may remember from high school geometry or trigonometry that the cosine of minus theta is just the cosine of theta, and that the sine of minus theta is just minus of the sine of theta. And therefore we conclude that the inverse of this matrix right here is given by this matrix right here. Now notice something interesting here. Notice that the matrix on the right is just the transpose again of the matrix on the left. We can check. If you multiply this whole mess out, you get this right here. Let's see, this first entry is just this times that plus this times that, and so forth. And then if you remember from trigonometry that the cosine squared plus sine squared is 1, then you recognize that the entries on the diagonal are equal to 1. And if you look carefully at the off-diagonal entries, you see that the terms cancel so that you get zeros. Okay, let's move on to the next homework exercise. What is the inverse of a 2D reflection with respect to a 45-degree angle? We'll see you in the next video.